In under a long time since its send-off, the James Webb Space Telescope, JWST, has reformed our comprehension of the universe. For researchers, the pictures it has caught open up additional opportunities in astronomy. While until the end of us, they are absolutely staggering to view. Cosmologists overall are stunned by a weighty disclosure. The JWST has caught far-off, city-like lights 7 trillion miles away. This disclosure outperforms assumption, extending our vast comprehension and starting hypothesis among researchers reading up the information for signs about these divine signals. The revelation recommends life beyond Earth, bringing up questions about extraterrestrial civilizations and the probability of life somewhere else. Join us as we unwind how the JWST caught city lights billions of miles from our planet. Sent off on Christmas Day 2021, the JWST means to be a further developed and strong imaging gadget than the Hubble Space Telescope. Its motivation is to obtain the most honed pictures of as-of-late distinguished articles. For example, planetary frameworks. Prior to jumping into the most recent discoveries, how about we check the Hubble Space Telescope's part in space investigation? The spearheading Hubble Space Telescope, HST, sent off in 1990, regardless functional, has changed space science. A joint exertion among NASA and ESA, it satisfies a fantasy from the 1920s made conceivable by mechanical headways. By the 1970s, the HST's primary mission is to convey high-resolution vast symbolism, empowering itemized investigation of divine items and developing our bits of knowledge into cosmic, heavenly, and planetary development. What's more, improvement as a crane reflector telescope, the HST accomplishes the centralization of light from space objects utilizing mirrors. Its essential 2.4 meters, 7.8 feet, reflect, alongside a more modest optional mirror, guides light to the central plane containing instruments for picture catching and information assortment. The Hubble is furnished with different gadgets that help assorted perceptions of the universe. These incorporate cameras that catch pictures of room objects, spectrographs that split light into essential tones for examination, and polarimeters that concentrate light polarization to identify properties of divine bodies. The Hubble's plan likewise incorporates space traveler overhauling capacities, considering fixes and instrument redesigns. The first overhauling mission in 1993 remedied a deformity in the essential mirror by connecting restorative optics. A sum of 5 overhauling missions have been led, with the final remaining one in 2009. The Hubble Space Telescope has for eternity changed our perspective on the universe, offering stunning symbolism of heavenly items and making historic revelations including estimating the extension pace of the universe, finding dull energy, and noticing the introduction of stars and cosmic systems. Hubble's inheritance reaches out past its revelations, pushing advancements in galactic advances and motivating new ages of researchers. The progress of telescopes like the JWST expands on Hubble's inheritance, promising more profound bits of insight into the universe and propelling our insight into the universe's set of experiences. The JWST's profound field pictures mean to analyze the most old worlds, pushing the age of the universe to its earliest stages. By utilizing the planetary group as an instrument, the JWST portrays brilliant items as their old predecessors could have seen them. Space experts use light year, the distance light goes in 1 year, to determine these unimaginable distances. The JWST first show featured this idea by displaying a profound field picture, sent off on July 11, 2022, by President Joseph Biden at the White House. This picture, like the Hubble's profound field pictures, focused in on a little fix of sky and grouped around 3,000 new items, for the most part far-off universes billions of light-years away. The JWST's profound field picture, like Hubble's, shows an apparently mediocre speck of the night sky. Anyway, within this small region, close to the SMX 0723 system bunch, there is an abundance of information to be mined. This titanic bunch, roughly 4.6 billion light-years away, goes about as a natural amplifying glass because of its colossal attraction force. This peculiarity, known as gravitational lensing, permits cosmologists to dig further into the past, coming to the extent of 13.1 billion light-years. The center around the obscure stretches out to the search for life beyond Earth. The huge number of far-off universes revealed by the JWST has touched off new logical requests. especially with respect to a specific arrangement of Earth-sized planets that could hold signs to the presence of extraterrestrial life in our grandiose neighborhood. This pursuit addresses the Fermi paradox, which questions the non-attendance of proof for cutting-edge extraterrestrial life notwithstanding the high likelihood of its presence. One star arrangement specifically compelling is TRAPPIST-1, found roughly 40 light-years from Earth. This star framework, with 7 Earth-sized planets circling it, is critical in the quest for tenable universes. NASA factors in different boundaries, for example, size, distance from the host star, and barometric organization position to survey a planet's capability to support life. The JWST as of late accomplished an achievement by estimating the temperature of TRAPPIST-1b, the main identification of light radiated by an exoplanet of its size and temperature range. This leading edge highlights the telescope's responsiveness and potential to reform how we might interpret rough planet environments. While the JWST investigates far-off universes, the Voyager missions continue to astound researchers closer to home. Sent off in 1977, Voyager 1 is now experiencing a secretive area at the edge of our planetary group. This unexpected excursion adds another part to the incredible history of the Voyager missions. At first expected to be short missions, the Voyagers have given a tremendous amount of valuable information and expanded investigation for space science. These discoveries reliably help us to remember the endless significance of curiosity and investigation. As indicated by researchers, interstellar space begins where the sun's attractive field and the sunlight-based breeze stop. Voyager 1 accomplished this achievement in 2012, while Voyager 2, a good ways off of 11 billion miles from Earth, entered this area in 2018. Strangely, new discoveries from Voyager 1 uncover astounding peculiarities at this limit known as the heliopause. These peculiarities incorporate eruptions of plasma and high-energy particles, testing past suspicions. This acknowledgement has driven specialists to presume that the heliopause, a long way from being a distinct limit, is a dynamic, ever-changing district affected by different elements from both inside our planetary group and the world beyond. In spite of specialized challenges and the brutal realities of space, Voyager 2 continues to yield significant logical information because of inventive arrangements created by NASA engineers. This is a continuous sign of humanity's persevering through want to wander into the obscure, moved by curiosity and the journey for knowledge. In our planetary group, Venus has too turned into a subject of restored interest later, previously being excused as aloof due to its outrageous intensity. Late perceptions by cosmologists have reignited logical interest in Venus. The revelation of phosphine gas in Venus' environment, a gas frequently related with natural cycles, has driven researchers to re-evaluate the planet. Despite the fact that phosphine is created by microorganisms on Earth, researchers are cautious to stay away from void rushing to make judgment calls, taking into account other potential sources. The search for life on Venus dives into complex contemplations like compound responses, planetary advancement, and potential alternative organic processes. Venus' set of experiences likewise indicates a more calm past, conceivably facilitating fluid water for billions of years, drawing matches with Earth. This closeness brings up interesting issues about whether life once existed or could still exist in Venus' brutal climate. As opposed to the searing intensity of Venus, the cold surface of Jupiter's moon Europa is likewise a contender for harboring life. Its subsurface sea, concealed underneath a thick layer of ice, raises the probability of life existing in outrageous conditions. The tremendous distance of these foundation universes extends the light they produce, moving it from the noticeable range into the infrared reach. This shift permits the JWST, explicitly intended to distinguish infrared light, to notice these antiquated worlds with outstanding clarity. By contrasting these perceptions and noticeable light pictures from telescopes like Hubble, cosmologists can piece together the great account of cosmic development. This examination offers a remarkable window into how systems have changed from their crude states billions of years prior into the glorious structures we see today. One especially amazing part of the JWST profound field picture is the speed at which it was gotten. Surprisingly, the telescope caught this information in just hours, exhibiting its remarkable effectiveness in cosmic system identification. Besides, the amplifying force of gravitational lensing isn't elite to cosmic system groups. The JWST likewise caught a dazzling picture of two connecting cosmic systems known as VV191. When light from one universe goes through the other, it gets contorted, giving hints about the residue properties of the mediating cosmic system. This newfound information has the possibility to disentangle novel mysteries about the fixings and development of systems. The compass of the JWST reaches out past investigating far-off systems. A new secret on the official site proposes a potential locating of auroras borealis on a brown dwarf, a heavenly body that lies between stars and planets. This finding is astounding because earthy-colored diminutive people lack the interior combination processes that power stars and create auroras. Specialists are attempting to decide the exact wellspring of energy supporting these auroras, with some proposing an undifferentiated from system to Earth's auroras, where methane discharges interface with the earthy-colored dwarf's atmosphere. This examination could prompt a new comprehension of these baffling, magnificent bodies. Another huge revelation by the JWST is the identification of a very enormous dark opening. This enormous dark opening, 40 million times greater than our Sun, is profoundly dynamic and eating up its environmental factors. Found by Dr. Lucas Furte and Ian at B College in Israel, the tremendousness of this dark opening proposes its critical effect on its host system's improvement. Luckily, this very gigantic dark opening lives a safe distance away, 12.9 billion light-years from our nearby planet group. Regardless of the massive distance, the JWST can peer through the huge vast bay to uncover its forceful taking care of conduct. The ruddy shade identified by the telescope is probably brought about by a thick cloak of residue encompassing the dark opening, hindering most light from getting away from it. This dusty cover likewise hides the genuine size of the dark opening. Anyway, when the JWST began sending its underlying information, researchers were especially amped up for three little items discharging a blood-red sparkle. These items may be quasar-like entities, very monstrous dark openings at the focuses of universes effectively eating up matter. The impossible-to-miss appearance of these items, with their glow concentrated inside a minuscule spot, raises inquiries concerning their tendency. Gravitational lensing, a whiz peculiarity where huge items twist light, gave exact size gauges in any event when packed by the lensing impact. These dark openings make up a faltering 1% of their system's aggregate mass, indicating their enormous size. A comparative way of behaving seen in other early universe very enormous dark openings sheds light on their development and their relationship with their host cosmic systems. Albeit numerous parts of this collaboration remain covered in secret, the JWST discoveries offer significant bits of insight. Separated from these weighty revelations, the JWST has likewise caught other captivating peculiarities. For example, a picture delivered by the European Space Agency, ESA, showed a little orange imprint, looking like a flipped question mark at the foundation of an image zeroed in on two youthful stars framing about 1,470 light-years away. Hypotheses range from far-off systems to other unidentified factors. Further examination is expected to decide the idea of this disclosure, which could open more secrets of the universe. The emphasis on the obscure reaches out to the quest for life beyond Earth. The presence of water, fundamental for life as far as we might be concerned, joined with energy sources from the Moon's geographically dynamic center, makes a convincing case for investigating Europa. Further missions like the impending Europa Clipper mean to explore the Moon's frigid covering, look for indications of life, and grasp its true capacity for tenability beyond our planetary group. The JWST's investigation of exoplanets offers new chances to look for tenable universes. One such exoplanet, K218b, situated in the tenable zone of its star, has given promising indications of potential tenability. The identification of gases, for example methane and water vapor in its climate, raises interesting potential outcomes. While not authoritative proof of life, these gases show the presence of processes that could uphold life. The variety of exoplanetary conditions, from gas Goliaths to rough universes, highlights the significance of preceded investigation and perception. The pursuit forever and the appreciation of life's shared trait inside the universe drive continuous investigation and logical interest. Examining heavenly bodies like Venus and far-off exoplanets extends how we might interpret the universe and offers glimpses into our planet's set of experiences and future. The joined endeavors of telescopes like the JWST and missions like Voyager and Europa epitomize humanity's constant interest in knowledge, expanding the skylines of our astronomical getting it.